Hello everyone, my name is Muhammad Alif with student ID number 2024322059 from the Information System Study Program Class C of Network Security lecture. And in this occasion, I would like to explain about my third practical report in network security course. So in this video, I'll focus on a complete practical implementation of an intrusion detection system, commonly known as an IDS. Specifically, we will go step by step through how to install, configure, and validate Snort on a Kali Linux environment. We will also write custom rules to capture live network traffic, to including ICMP pings, FTP access attempts, and malicious port scanning simulations using Metasploit. Let's dive straight into the system. So first, before executing any commands, we need to ensure our virtualized environment has proper internet connectivity to fetch the necessary package. To do this, open your VirtualBox machine net settings, navigate to the Network tab, and attach your adapter to NAT or Network Address Translation. This gives our Kali Linux OS access to external repositories. Once the network is configured and our terminal is open, we sync our local package index and install Snort. The command used here is sudo apt update and then sudo apt install ysnort. You will be prompted to enter your super user password. After entering it, the system automatically downloads the Snort binary along with these crucial dependencies, such as libdac tree and default rule subsets. This process takes just a few moments depending on your network speed. Okay, next, with Snort installed, our next major phase is setting up the directory architecture for our custom signatures and logging mechanisms. We create two essential directories using these commands: sudo mkdir p add snort rules and sudo mkdir p var log snort. The first directory acts as the dedicated storage repository for our custom security baselines, while the second stores our post-event traffic logs for future digital forensics. Now let's write our custom detection rules. Now open your local rules file by running sudo nano add snort rules local rules. So inside this empty file, we define three signature-based rules to capture specific network behaviors. So rule 1 for ICMP detection, art ICMP any. This true rule tells Snort to trigger an alert flag whenever an ICMP packet, such as a network ping, is sent from any source IP and port to any destination. We assign it a Unix Snort ID or SID of 100001. And then rule 2 for FTP exploit monitoring, alert TCP any. This actively tracks inbound TCP traffic, specifically targeting port 21, which is the default port for FTP service commonly targeted during exploitation phase. And then alert TCP any. To prevent false positives, we incorporate a detection filter. This rule monitors if a single source IP initiates more than 10 TCP connection attempts within a tight 5-second window. If it crosses this threshold, Snort classifies it as an active port scan. Once these rules are typed precisely, save and exit the nano editor by pressing Ctrl X, then confirming with Y and enter. And then, before initiating live network surveillance, we must verify that our configuration file syntax is fully accurate and free of errors. So I do this by pointing Snort to its core configuration file using the test flag sudo snort snort conf. And to executing this command, initiate a dry run parsing process. Snort reads our snort conf file, links our custom rules, and initialize its internal preprocessors. As you can see from the terminal output on my screen, it shows Zero warnings or errors, ending with the message, Snort successfully validated the configuration. Snort is stating this means our configuration is solid and ready for deployment. And then network bridging and running Snort. So to conduct a realistic attack simulation, Snort needs to be on the same local network layer as our testing machines. Go back to VirtualBox settings, switch the network mode from NAT to bridge adapter, and select your active hardware network interface. And to apply this network change smoothly inside Linux, restart the network stack by running sudo systemctl restart network manager. Now let's verify our assigned local IP address using IPA. As soon as the H0 interface block, my machine has been assigned the IP address 192.168.136 on a 24-bit subnet mask. With our target IP confirmed, we launch Snort into live console monitoring mode. We execute sudo snort, it is our group. And then the alert fast flag instructs Snort to dump brief immediate threat notifications directly into our screen the millisecond a signature match occurs, monitoring our primary network interface, ETH0. Now for the most exciting part, the live security testing, because Snort is actively hijacking control the terminal session to display alerts. Okay. And to conclude, this practical experiment confirms that Snort is a highly effective, adaptable, and lightweight open-source IDS solution. By utilizing a defensive layer via signature-based detection running in real time, it successfully generates immediate, actionable intelligence to protect assets. When integrated alongside robust stateful firewall like Linux iptables, it forms an excellent defense in-depth framework capable of safeguarding core corporate data infrastructures. That concludes my video explanation of chapter 3. Thank you very much for your guys' attention and have a great day. Thank you.